So, my family is very competitive,
No, you're wrong.
I quit!
as you can see. And one of our favorite games is Clue. Now, I'm very good at math and very good at programming. So I was wondering, could I use those skills in order to make an AI that could beat my family at Clue? Now, you may ask, what is Clue? Well, Clue is a murder mystery game. In Clue, there are 3 different kinds of cards: people, weapons, and locations. One of each is sealed away in an envelope before the beginning of the game. And the whole point of the game is to try to figure out what is in that envelope. Now, the rest of the cards are shuffled and distributed to the players. And on your turn, you can make a guess as to what's in the envelope. And if somebody has a card that disproves you, aka it's not in the envelope, they will discreetly show you. And then the next person will take their turn. And whoever can figure out exactly what's in the envelope first wins. So you may ask, how are we going to make this AI, right? Well, in order to do that, we can treat each combination of player and card as a Boolean, so either true or false. And we can add constraints to this very large problem using some logical operations, including and, which just means both of them have to be true, or either one of them could be, or not, meaning it flips the value from true to false or false to true. Then we can encode all this knowledge in what's called a knowledge base using something called CNF. And then we can use the entailment operation in order to query a symbol from the knowledge base to basically see if it's forced to be true or forced to be false. If it's forced to be true, then a player must have the associated card. If it's false, then they cannot have the associated card. And if it's unknown, then we just simply don't know yet. And all of this can be used to determine exactly which players have which cards given enough information. Now, I'm not going to get into the technical details here for the sake of time. However, if you want to see it, it's in the link in the description for the GitHub. So now that we have the information about the state of the game, we now can go on to step 2, which is making a good guess. Now, in order to do that, we're going to use something called heuristic modeling. And what that basically means is we're going to iterate over all of the possible guesses. Now, I only drew 3 here, but there's hundreds. And we need to assign some kind of value to it. Now, in order to do that, we're going to write a function that will count how much new information we gain based on this guess, on average. And in order to do that, we simulate all of the possible outcomes and assign them a score based on how much new information is deduced. And we put a higher weight on information that is in the envelope, because obviously that's the end goal of the game. Then, because the probability, we just assume it to be equal for all of them, the probability of any particular outcome happening is just 1 over the number of possibilities, obviously. And then, to get the expected value of this node, we just do the summation of the probability times the heuristic score, which is here. As you can see, this one averages 3, 2, and 1.5. And then all we have to do is simply pick the one with the highest score, which in this case is 3.0. So we are going to pick this guess in this case. Again, technical details in the link in the description down below. Anyway, time lapse. Thank you guys so much for watching. Since this is my first real video on this channel, a little bit more about myself. My name is Alex and I'm an engineering student. This channel is going to serve as a portfolio or demonstrator of sorts for all of my projects. I have a few more projects cooking up in the labs right now, so stay tuned for those. If you want a more technical description of this project, I'm happy to make a longer form video. Just leave a comment, please. And you can check my GitHub for the code. So until next time, this has been Giraffe Labs. Thank you.